In this video lesson, we will learn about circle sectors. So first of all, we have circles. Circles are the set of points equidistant from the center. So they're all at distance equal to the radius from the center. And a circle sector is literally when we cut out a sector of the circle, meaning we pick 2 points on the circle, and then we draw the 2 radii, and we get a small and a large sector. And this outer perimeter is called an arc. So this is the minor arc because it's the smaller of the two. The larger one, which is on the other side, is called the major arc. And the portion inside is called the minor sector. And then on the opposite side, just replace minor with major. Remember that minor means small and major means big. So we have the major arc. And that interior, the interior part, is the major sector. So now we're going to learn how to calculate their areas and lengths. So here we're back to just the circle and its 2 sectors. And let's say the smaller sector has x degrees as its angle. So of course the circle has the radius r, and the question is, what is the area of the small sector? And the answer is, it's x degrees over 360 degrees times pi r squared. So pi r squared is the area of the whole circle, and since the sector has x degrees out of 360 of the circle, we multiply the whole thing by x degrees divided by 360. So if that makes any sense, the x degrees indicates that we have x out of 360 of that circle. And similarly for the length that I've highlighted in the drawing, the length L is x degrees over 360 degrees times the circumference of the circle, 2 pi r. So once again, you take the whole circumference or the whole area, and you multiply it times the portion that the sector or arc takes of those. And that portion is determined by the degree, so x over 360. So now we're going to do a few example problems with these formulas to make sure that we understand. What is the length along the small arc? What is the area of the small sector? So this is a very straightforward application of the formulas we just learned. So here is the minor arc, the small arc, and we're going to label it with L. And to calculate L, and of course we're going to label area with A, and L equals to x degrees over 360 degrees times 2 pi r. And now we plug in values. As we can see, x degrees is 52 degrees, so just plug in 52 there. So it's 52 degrees over 360 degrees times 2 pi, and the radius is 7. And this we just plug into a calculator. And the calculator gives us the answer. The answer is 6.36. So that is the length of the minor arc, or the small arc. So I write it up there and free up this room to calculate the area. And I don't erase everything because the formula for the area is very similar. that x over 360 is the same in both formulas. Just remember that. And then we multiply it times the area of the whole circle. So now we just do the same thing. We plug in 52 degrees, and we plug in r equals 7. So times pi 7 squared. And once again, we use a calculator. And the calculator gives us the answer, 22.24. So we have length, the length is 6.36, and the area is 22.24. And that concludes this problem. All right, on to the next problem. What is the radius of the circle? And we're given, up here it's labeled area is equal to 23, and the angle is 97 degrees. So this time we're doing a sort of reverse problem. Usually you'd be given the radius and you'd be asked for the area, but this time it's the opposite. So we plug in the formula, a equals x degrees over 360 degrees times pi r squared. And the formula we're using is still the same, but this time, instead of getting the area, we're going to have to solve for the radius. So we plug in the things we do know, 23 for area, 97 for x. We get 23 equals 97 degrees over 360 degrees times pi r squared. And now we got to solve for r. So we get r squared equals 23 times 360 over 97 times pi. So then to find r from that, we just have to take the square root of the entire expression on the right. And this you just plug into your calculator, and it'll give you the answer, r equals 5.21. And there it is. All right, now we're ready for the final problem. What is the area of the highlighted sector? So a lot of times you'll have these highlighted portions and you need to figure out what their areas are. In this case, we use the fact that the angles here are opposite angles, so they're equal. So both of these are 61 degrees. And actually what that means is that you could pretend that the highlighted area is one big sector, and that big sector, not a major sector, but that big sector would have 61 plus 61 degrees, so 122 degrees as its angle. Just imagine that you take one of those highlighted regions and rotate it over and join it to the next one. So that's 2 times 61 degrees over 360 degrees in our formula. Another way to look at this is that we count the same sector twice. In any case, our 61 over 360, we have to multiply by 2. And then we plug in r equals 4, plug this into our calculator, and get the answer is 51.10. Well, thank you for watching this video lesson. I hope it helped.